All right, probability. Probability is the likelihood or chances of something happen. I want you to get in your head kind of this number line with 50% right in the middle of it, 0% at the bottom of it, and 100% at the top of it. If something is 100% chance, then that means it is certain or guaranteed. If something has a 0% chance, that means it is impossible, can't happen. Right in the middle is a 50%, and that means it's equally likely, and that's why they do things like flip a coin to figure out who gets the ball at the beginning of a football game. Now, anything lower than 50 down to 0 is what we call unlikely. And anything over here is likely. So it can have a 50% chance, it can have less than 50, which makes it unlikely, it can have more than 50, which is likely, or it can go all the way up to certain at 100% or impossible at 0%. And this is a decision maker when I think about things. I so much of my life is determining what the likelihood of success is and then making a decision whether to try something or not based on that. Okay? So, over here on the right-hand side, I have some coins. I have 10 coins. I have 4 quarters. Those aren't quarters. 4 pennies, excuse me. I have 3 quarters. I have 2 nickels. And I have 1 silver dollar. And I'm going to do just a couple probability problems with that. So, a lot of times the way they'll put it is they'll put a P for probability, and then they'll put the event in here. So what's the probability that I pick a nickel? If I were to have those all in what is called a random choice or random selection, that means that each one of them has the exact same chance of being chosen. I would be able to find the probability of getting a nickel by going up to this thing, which is what I want you to memorize, and that is the number of ways it can happen on top of the total number of outcomes. Well, how many ways could I get a nickel? 1, 2 winners out of 10 possible things. Now I could simplify that. That would simplify down to 1/5. I could divide it and change it to a decimal, 0.2. I could move the decimal 2 places and make it 20%. Now I have that as my probability. By the way, if I graph 20%, it would be right down in here, unlikely. So I'm not putting my money on that. That's what I a lot of times say is, by the chances, are you willing to like bet on that? And the answer is I wouldn't, not at 20%. I'm not going to get that very often. I'm going to win it about 1 out of every 5 times. Let's try another one. What if I said the probability of getting a penny? Well, now I count up how many pennies I have. 1, 2, 3, 4 out of 10. Could simplify that. That's 2 out of 5. Divide it becomes 0.4. Move the decimal twice, it becomes 40%. Well, I have twice the chances I used to. It was a 20% chance. Now I have a 40% chance. I'm up here further, but guess what? I'm still unlikely. Still not going to put my money on that. We go one step further. This one some people think is a compound event, but you're only picking one time here. What if I said, what's the probability I get a penny? Or, and I'm going to put that word big because we're going to come back to it, or quarter. Well, now I count up my pennies and quarters. I have 1, 2, 3, 4, 5, 6, 7. That's 7 out of 10. Can't be simplified. I divide it, it becomes 0.7. Move the decimal 2 times, it becomes 70%. Now I'm up in here. Now it's likely that I have more winners than I have losers, right? So now I would consider that likely, and maybe I would put my money at a 70% chance. The word or, I want you to understand, means what we should do is we should take the 2 probabilities, the probability of the first plus the probability of the second one. So if I say either or, you're going to add the probabilities because we have multiple ways to win it. Now we have a twister spinner, and I might say something like this. What is the probability that I spin a green? Well, I could count them all up. I'll start on this green right here. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 possible things. And how many of them are green? 1, 2, 3, 4. You might notice that you could simplify that down to 1/6, right? That means that each one of these 4 pieces have 6 of those in there. So 1/6. We could divide that and get 0.16 repeating and move the decimal 2 places and get 16 2/3% or 16.6 repeating percent. Okay. That'd be unlikely, right? Okay. And you can spin, and I only have a 16.6 repeating percent chance of getting it, and I did not get it. Okay. This one also has two different things though, because this has a whole section of right foot, left hand, left foot, right hand. And so this is where we're going to get into a probability that is not just one event, but two events. So now I'm saying, what's the probability I get green, just like I just did a moment ago, and right hand? Now two things have to happen, right? I have to get right hand and green. Well, what's my probability that I get a right hand? Isn't this right hand section, isn't it 1 out of 4 sections? So the probability of getting the right hand is 1 out of 4. And the probability of getting green, right, is well, we simplified it to 1/6, right? Now the probability of, do you remember what we did on the first one? I said probability when it was like this or, and I said, okay, a penny or a quarter, we add. If it's and, that means this has to happen and this has to happen. We multiply those probability, and I have 1 chance out of 24. 1 chance out of 24. And look at how many are in the right-hand section that are green. 1 out of how many total outcomes? 24. Okay, so 1/24th. And remember, and means we then have to multiply the probability. So we're going to change that just a little bit. And now we're going to say, what's the probability that I get right foot and blue and I flip a heads with a coin? So now I have another probability, right? So what's the probability I get right foot? Well, 1/4. What's the probability I get blue? Well, there are 4 out of 24, or 1/6. And what's the probability I get a heads? 1 chance out of 2. If I want to get all 3 of those done, I have to get the first one and then the second one and then the third one. So I would have to take 1/4 times 1/6 times 1/2, which is 1/48. That's roughly a 2% chance, right? Not a very good chance at all to get that. So we'll try it out just to see. I'm looking for right foot, blue, and heads. I didn't get right foot. I didn't get blue. And I didn't get heads. I got none of the 3 that I was looking for, right? Because really, I had a unlikely chance of getting the right foot, an unlikely chance of getting a blue, and I had a 50-50, an equally likely heads and tails, but I, of course, didn't win that one either. Okay? So, if you can think about that in terms of means add the probabilities, and then means more things have to happen, so you are multiplying the probabilities, then I think that will help you. So I'm going to go back to the coins real quickly. Again, I have 10 coins. Okay, so probability of a single simple event will be out of 10. So if I said probability of getting the silver dollar, remember, we're assuming these are all fair games, fair chances, right? So how many silver dollars do I have? 1 out of 10. I could change that by, of course, dividing. Becomes 0.1. I can move it 2 places. That becomes 10%. It's unlikely, right? Okay. Let's try again. What if I said the probability of nickel or a quarter? Or no, let's do nickel or silver dollar. We'll do nickel or silver dollar. I have 2 nickels. So I'm just going to write that probability as 2 over 10. Silver dollar, 1 out of 10. Probability either or means I win either way. So let me add that up and get 3/10. Now I told you earlier, or maybe I didn't say it, but a lot of times I teach this by saying either or and. That's where a lot of kids kind of struggle. Remember, or, it means we need to add, and means something else has to happen. 2 things have to happen. So the best example I've ever come up with, I think, for this one is if you come home and your parents tell you, listen, you can either take the trash out or clean the garage. Don't you have 2 ways to make your parents happy? Either one of them works because they gave you a choice. You can either do this or this. And of course, you're probably going to choose take out the trash because it's going to be quick and you won't have to worry about it unless you don't have a garage, and that would be the easiest one. But for most people, that's going to be easier just to take out the trash. But if you come home and they say, what's the probability, or well, not what the probability, your parents probably aren't math teachers, but if they said, you need to take out the trash and then clean out the garage. Well, if you take out the trash, are they happy? No. If you clean up the garage, are they happy? No, you have to get both of those accomplishments, so it becomes more difficult. Your probability of making your parents happy goes down. So let's do another one like this. What is the probability? We'll do the same one we just did. What's the probability to get a nickel? And then the silver dollar. And then I'm going to mention one thing here. You got to be really careful. I'm going to say with replacement, and I'll explain what that means as I go. That means I'm going to choose one at random, right? And what are my probability of getting a nickel? Well, 2 out of 10. What's my probability of getting the silver dollar? If I replace the nickel back in, then the probability is 1 out of 10. And then, of course, and then means I need to multiply those. So now I would have and I can cross-simplify. So that would become a 5 and a 1. And now I have a 1 out of 50 chance of getting that done. A 2% chance of getting that done. Highly unlikely, right? I'm going to change that problem just a little bit and say without replacement. Without replacement means I'm choosing. So let me go ahead and say probability nickel. And then the silver dollar. But this time we're doing it without replacement. Okay. Well, let's say I get the nickel. Okay. And now I don't put it back in. So now there were 2 out of 10. Now, I still have 1 silver dollar in there, but it's out of 9. This is what are called dependent events because the probability of the second one changed after we did the first event. So if the probability of the second one changes, then you've got what are called dependent events. And now I would still multiply. This time can't cross simplify, but I could simplify up and down on this one, right? And get 1/5. And then I get 1/45. So you notice the probabilities are not the same because I've changed the probability when I took out one of the coins, if that makes sense to you.